in solving exponential equations, the first thing you want to do is you want to notice where the variable is. So an exponential equation has the variable in the exponent. So if you spot that the variable is in the exponent, then we need to isolate as much as we possibly can the base plus the exponent. So we would want to have something like e to the x equals something. If you were starting off with an equation that looks like 2e to the x is equal to 10, that is not an isolated exponent because our exponential expression, because the base is e, the exponent is x, and you would need to start by dividing by 2 to get an isolated base plus exponent. So once your base and your exponent are isolated, you have to figure out some way to get that x out of the exponent. And the way that we get the x out of the exponent is actually using our log properties. So we take the natural log of both sides, and then in this particular class, we're just concerned with a base equal to e. And so when the base is equal to e, what we'll see is that the same base, for natural log you have a base e, for the exponential you have a base e, so those bases will cancel. And the beauty of this is once the bases cancel, then the natural log is gone, the e is gone, and you will just have a number equal to something or a variable equal to something. And so that will be an equation that you can then very straightforwardly solve. So if you look at this example here, the first observation that you should make is that it is an exponential equation because t is in the exponent. The variable is in the exponent. So my first step is I try to isolate, and when I isolate it, I am concerned about the base plus the exponent being by itself. So if identifying the base as e, the exponent is t, that base plus exponent is by itself. So step 1 is done for us. So now we need to look at getting this t out of the exponent. And the way we do that is by applying the natural log to e to the t equals the natural log of 100. So we apply on the left-hand side the natural log of this side, natural log of this side. Now, the beauty of this and why we're doing this is because now we notice that natural log has an understood base e. Our exponential term also has a base e. So these same bases will cancel. So the natural log will cancel, the e will cancel, and you will now have t out of the exponent equals natural log of 100. Now, you then can compute this, or you could just keep it as natural log of 100. If you compute natural log of 100, you will get approximately 4.605. All right, let's look at a slightly more complicated question here, where we have e to the negative 0.02t is equal to 0.3. All right, so again, the first observation is, okay, my variable is in the exponent. So that means I want to isolate the base plus the exponent. And when you look here, our base is e, exponent's negative 0.02t, that is isolated. So my next step is I've got to figure out a way to get this t out of the exponent. So I will take the natural log of both sides. Okay, now once I take the natural log, the whole reason why we're doing that is because the natural log has a base e, this exponential term has a base e, so those will cancel. And so we will be left with negative 0.02t equals natural log of 0.3. So that's an equation that we can solve. It's the same as if it was like natural or negative 0.02t equals 10, we would just divide by negative 0.02. So we'll do that. We'll divide by negative 0.02, divide by negative 0.02. Now, do be careful when you type this in on your calculator, because what we need to do is we need to evaluate this expression. And when we do that on our calculator, we have to be very careful that we end the argument at 0.3. So usually the calculator will have a little parenthesis, or you might have to type in the parenthesis, but you'll want to put natural log 0.3, close your parenthesis to end the argument, and then divide that by negative 0.02. So if you just type in natural log 0.3 divided by negative 0.02 and you don't hit an enter for the parentheses or anything, what happens is your calculator assumes that this 0.02 is part of your argument. So you need to be very careful to close your argument off and then divide by negative 0.02. So when you do that, you should get that this is approximately equal to 60.1986.